So we're working out of the OpenStax Statistics Chapter 8 examples, and we're talking about the confidence interval with acupuncture patients. So just as a reminder, you can always access the book for free. You can look in the description of the video for a link to the book. You can also get the Excel workbook for free. Just go to divideandconquermath.com and go to the OpenStax Statistics section. Okay, so suppose you do a study of acupuncture to determine how effective it is in relieving pain, and you measure sensory rates for 15 subjects with these given results. So we're going to use the sample data to construct a 95% confidence interval for the mean sensory rate for the population for which you took the data. So I really like this example because this is one where you can kind of imagine how you might do something like this. So notice with the information that's given, so, just like we have with our previous tabs, we want to figure out what data have we been given. I can see here that my N is 15, but that's like really all I can tell from my given from what is written here, right? So as far as what my standard deviation and my mean are, I am going to have to compute that myself. So for my mean, I'm just going to use my average formula. So I can easily calculate that. But we want to be careful now when we get to our standard deviation. So remember, I've told you in the previous tabs to watch out for what type of standard deviation you have. In this case, as you read this problem, there's nothing in this about what the population standard deviation is. All we have is this data, and so this is what we're going to have to compute our standard deviation off of. And that's totally fine. We can do that. We'll use our standard deviation sample formula, so it's that .s formula, to compute our standard deviation. But what that specifically means now is that this is a standard deviation of S, not sigma. And since now we are in S and we have a sample size of 15, we have to use students T. Okay? And so again, why? We don't have the population standard deviation. Our N is 15, so that's what we've got to use. So for that then, we need to also compute what our degrees of freedom are. So I take whatever my N is minus 1. So I have to use that standard deviation. So as far as computing my confidence interval, everything still really works the same, except now I have to switch everything into students T. But if you're like thinking about how things might look, so my students T, it looks very similar to the standard normal distribution. And so I still go through the same steps. My alpha is going to be found by taking 1 minus that 0.95, and then I'm going to take that alpha and I'm going to divide it by 2. But now, for my critical value, I'm doing everything on students T. So this right here, I'm kind of writing off on the side here, but just to be clear, this is now students T that we're in, but all of the logic is still the same. So I'm still thinking about finding the critical value at the tail ends on each side here. So this amount of area is going to be that 0.025, so it's that alpha value divided by 2. So I have this amount of area in each tail, and it's still the same idea of what is this value down here. But instead of this now being a z-score, this is now a t-score. It really works the same. It's just this like very tiny change in the logic, and you want to pay attention to it because it's going to come up a lot in the other chapters. So you just want to pay attention to which distribution you're in. So instead now of using my norm.s.inverse, I'm going to use my t.inverse. Now, again, we're using that because we're in the students T. I also want to point out one funny thing with Excel. When you use this, you can either use the .inv or the .inv.2t. It doesn't matter which formula you use, but you should probably think about what's going to make the most sense to you. Now, personally, what I like to do is I just like to use the same logic from the standard normal distribution. And so I like to just take, what is that probability in each tail, that 0.025, or you can take your alpha divided by 2, it doesn't matter. And then of course it's going to ask you for your degrees of freedom. So you can go this route, and of course this is always going to return to the left, so you can take the absolute value of that, and if you want to round it, you can also round it. So the other way that you could do your critical value, I'll just show you. So you can use that t.inverse, but you can use this .2t formula. And if you want to use that, it wants to know what is the total area in both tails. So then I could just use my alpha and then my degrees of freedom. And so notice just when we do that, it automatically returns a positive critical value. So two different formulas doing really the same thing. It's just, in this case, I just wanted one side of the tail. And in this side, it assumes that I'm doing a two-tailed test. Tomato, tomato, I just like to point out what those are. You do what's best for you. Okay, so from here, now I'm going to calculate my error bound. And my error bound is the exact same way as before. I take that critical value, I multiply that by my standard deviation divided by the square root of n. So there's my error bound. And so then for my confidence interval, it's still the same idea. I'm going to have that high versus that low value. So I'll take my mean plus my error bound and my mean minus my error bound. And so there you go. And so the 95% confidence interval is going to be this 7.3 to 9.15. And so there you go.